Hello CAT aspirants. In this session on Bell the Cat, we'll try to understand certain myths which surround the test. The student community looks at these myths as obstacles and therefore there is a hindrance in their performance. So we'll try to understand how we can look at the ground realities and have a better connect with the CAT questions. We'll try to look at certain questions and try to dispel the myths with the help of these questions. The first myth and the most obvious one is that something which is simple, something which is apparently obvious should qualify as the answer. And this assumption becomes even more critical when time is less and students have to respond to the questions under a certain time crunch. Let's take a look at one of these questions. If A upon B plus C is equal to B upon C plus A is equal to C upon A plus B is equal to R, then R cannot take any value except, then there are four options there. Option 1, 1 by 2. Option 2, minus 1. Option 3, 1 by 2 or minus 1. And option 4, minus 1 by 2 or minus 1. Now if you look at this question carefully, the topic from which this has been sourced is equations. And the equation which has been given is a very simple one. A upon B plus C is equal to B upon C plus A is equal to C upon A plus B is equal to R. So we have to find the possible values which R can take. Now, an immediate application of the law of equality of ratios will take us to one of the options, and that is, if all this is true, then obviously each of these is equal to the sum of numerators by sum of denominators, which makes it A plus B plus C upon twice of A plus B plus C, which makes it 1 by 2. So 1 by 2 is definitely one of the options there. It definitely qualifies as one of the options. And it is very obvious that most of the test takers will arrive at 1 by 2 as one of the options. Now the problem is, the minute you get 1 by 2, somewhere in the working process, you jump to it as the answer. Now this is where you need to be careful. And going back to where we started from, 1 by 2 is too obvious to be true. So we have to dig a little deeper and then see how subsequently we can proceed to the right option. So far we have decided that 1 by 2 should surely be there as a part of the answer, which means that the answer is either option 1 or it is option 3. Options 2 and 4 are therefore eliminated. Now it narrows down to either 1 by 2 or a combination of 1 by 2 with minus 1. So the next level, the next challenge in fact, is to verify whether minus 1 is possible or not. So we work top down, we work backwards. We assume that minus 1 is a possible value. So A upon B plus C is equal to B upon C plus A is equal to C upon A plus B is equal to minus 1. We assume that the value of R is minus 1. If this is true, it means that, so when is this possible? This is possible when B plus C is minus A, C plus A is minus B, and A plus B is minus C. Or we can say B plus C is minus A, C plus A is minus B, and A plus B is minus C, which means that A plus B plus C should be equal to 0. When this happens, minus 1 is also a possibility. Hence, the answer is option number 3, half or minus 1. So what we are trying to understand here is that whatever is apparently obvious, whatever apparently qualifies, may not necessarily be the answer. Obvious may be devious. Let's look at another myth which students typically are driven by when they solve the questions, and that is lengthier questions are tougher. Lengthier questions are more difficult to handle. We do understand that lengthier questions would mean proportionately more investment in terms of the time which you need to read the question. But that may not mean that a lengthier question is always a tough or a difficult question. Let's take a look at this question. A train enters a tunnel AB. Inside the tunnel is a cat located at a point that is 3/8 of the distance AB measured from the entrance A. When the train whistles, the cat runs. If the cat moves to the entrance of the tunnel A, the train catches the cat exactly at the entrance. If the cat moves to the exit B, the train catches the cat exactly at the exit. What is the ratio of the speed of the train to that of the cat? Now, as I said initially, the challenge is to read the question. If you are able to read the question and if you conceptualize it as you read it, I'm sure you will be able to process the question favorably. In fact, in the options given here, it is fairly obvious that only one option is such that the speed of the train is greater than that of the cat. In all other options, options 1, 2 and 4, it is the other way around. Hence, there is no spade work required. The only thing which you have to understand is, since the train is able to catch the cat at the exit B, it means that the train is faster than the cat. Therefore, the answer should be option number 3. However, we'll also try to understand what typically goes on in the student's mind and how he or she approaches the question. The first thing which students typically do is they try to plot it as a line AB, which is indicative of the tunnel. The cat located at a distance which is 3/8 of the length of the tunnel AB from point A. Now, this is where we suggest that you need to take values which can simplify your calculation. If you look at the question carefully, there are no absolute values. It's only relative. What is eventually asked is a ratio. So you can generously assume the length of the tunnel as a certain number, and then calculations can go around it. And the clue given is that the cat is at a distance 3/8 of the length of the tunnel from point A, which somewhere has a vibe that the length of the tunnel should be taken as 8 kilometers. Now, if the length is 8, it means the cat is at a distance which is 3 kilometers from point A, and the remaining distance is therefore 5. Now, the train D is approaching the tunnel from point A. It whistles, the cat runs. If the cat runs towards A, the train catches the cat exactly at point A. It basically means that during the time the cat covers 3 kilometers, this is the time taken by the train from wherever it is to enter the tunnel or to reach point A. Now we apply this clue, this particular hint in the other direction. Suppose the cat runs towards B and not towards A. Now the clue is, during the time the cat covers 3 kilometers, that is the time taken by the train from wherever it is to enter the tunnel, which basically means that when the cat has traveled 3 kilometers towards B and therefore is at a distance 6 kilometers from point A, the train has reached the tunnel. Now, if the train has to catch the cat at point B, during the time the cat covers 2 kilometers, the train has to cover 8 kilometers. That is the length of the tunnel. Or in other words, the ratio of the distances covered is 8:2. Since time is a constant, we can say the ratio of their speeds is 4:1. Hence the answer. Now, this is obviously an attempt to prove to the student community that lengthier questions may not always be tougher questions. They may not always prolong. They may not always take more time in terms of reaching the answer. Alright, this is another popular myth that whatever is given in the question has to be used for reaching the answer. This is not true, this may or may not be true. So I think what we need to understand here is abundance may be redundance. Let's take a look at this question. Two boats traveling at 5 and 10 kilometers per hour head directly towards each other. They begin at a distance of 20 kilometers from each other. How far apart are they in kilometers 1 minute before they collide? And 4 options have been given. Now, let's take a look at the working methodology. We have these two boats traveling towards each other. The speeds are 5 and 10. Now, the units are important here. Kilometers per hour. Since they are traveling towards each other, it means they are traveling in opposite directions. In other words, the relative speed is 15 kilometers per hour. 15 kilometers per hour. And the initial distance of separation has been given as 20 kilometers. This distance which separates them is 20 kilometers. The problem with the question is too much data given there. Do we actually need this value which is 20 kilometers? Do we need to work around the initial distance of separation? Well, no. We don't need that information, because what he finally wants to ask you is how far apart will they be 1 minute before they collide. Now this is where the student faces a kink. How far apart will they be 1 minute before they collide, which basically translates into what is the distance which the boats will travel in 1 minute. So we know that this equation, distance is equal to speed into time. This equation never goes wrong. You have to calculate the distance which they will travel in 1 minute. Speed is 15 kilometers per hour and time is 1 minute or 1 by 60 of an hour. So the answer is therefore 1 by 4 of a kilometer or 250 meters. Hence, the answer should be option number 2. Now, we do not require this data which is 20 kilometers anywhere to reach the answer. The message for everybody here is that please make sure that whatever is given to you may not necessarily be required to reach the answer. As a manager, when you start working in the organization, you're not supposed to use every possible piece of data which comes your way, right? So you have to be efficient as well, and this is where your myth needs to be understood. Abundance may be redundance. Quicker can avoid flicker. Now, quicker means that there may be a faster approach to solve a question, and it can avoid, the length and the rigor to arrive at an option otherwise, which would basically mean lesser time required if you are able to apply smarter techniques. Let's take a look at this question. If a plus b plus c is equal to 0, find the value of a to the power 4 plus b to the power 4 plus c to the power 4 divided by this expression. Now, immediately when the student looks at this, the understanding somewhere is that this is a question which is linked to the formula of a plus b plus c whole square, an application of that particular formula, and the student starts working around this particular formula, and what finally comes down is a time-consuming activity. Since we are required to be efficient, we are required to be time smart, we need to look at quicker approaches wherever applicable, wherever possible. Having said that, a look at the question again. You can easily infer that in this question, all variables A, B, and C are going a similar treatment. Each variable undergoes a similar treatment, which basically means that the function is symmetrical, which basically means that you have the liberty to take values which satisfy this equation, and you can take random values and plug them in and get the answer. For example, we can take A as 1, B as -1, and C as 0, because this satisfies the equation A plus B plus C is 0. There is no other condition imposed on the three variables. The minute you do it, you just plug in the values and you figure out what is the answer, right? So looking at the question, just plug in the values. So you'll get 1 plus 1 plus 0 upon 1, which makes it 2. So 2 is the answer. Option number 3 is true. Why? Because one of the variables is 0, so 2 of these terms will become 0, and one such term will become 1, and the numerator is 2. So 2 by 1, the answer is 2. However, you need to be careful that a quicker approach may not be possible in every question. So do not waste more time in discovering whether a quicker approach is possible or not. But if you've practiced enough, then this will probably come to you as soon as you read the question. Rough may not be tough. Rough is, of course, the level of difficulty of the question as perceived by the student. The roughness is decided by so many parameters. We just discovered a while back that length is one such parameter. The other such parameter is the topic from which the question has been taken. If you take a look at this question, 3 labeled boxes containing red and white cricket balls are all mislabeled. It is known that one of the boxes contains only white balls and one only red balls. The third one contains a mixture of red and white balls. You are required to correctly label the boxes with the labels red, white and red and white by picking a sample of one ball from only one box. What is the label on the box you should sample? The minute the student reads the question, there is an instant connect with the probability, theory of probability. And these typical questions on different colors of balls would take the student to modern maths and topics like permutation, probability, combinations. And most of the students would hold back from reading the question further because of this particular perception. So what you need to understand is that apparently whatever is tough may not be tough otherwise. So you need to explore the question further. For example, in this case, it is fairly obvious that options 1 and 2 are equally good or bad. The outcome would be pretty much the same. We are left with only options 3 and 4. So we need to verify whether we can identify the right color with option number 3 or not. If you can do that, then this will be the answer. Otherwise, 4 will be the answer. So a quick working here. We have these 3 boxes. Red, white, and red plus white. And they're all mislabeled, which basically means the red box may have either white or red plus white. The white box may have either red or red plus white. And the red plus white box may have either red or white balls. So what we do is we pick up one ball from this particular box. And suppose that ball is a red ball. If it is a red ball, it obviously means that this box should be labeled as red. Why? Because a combination of red and white is not possible in this box. If this has been identified as red, then obviously this option is out, which means the box which is mislabeled as white will have red plus white, and the box which has been mislabeled as red will therefore have white. A similar treatment would be applicable if you take out a white ball from this particular box, which basically means the answer is option number 3. Now this gets us to an end of this particular session. What we were trying to understand, that perceptions can spoil your case in this kind of a test. Students over the years have been making these perceptions and they need to be dispelled. The truth needs to be decoded. We need to understand that whatever is a perception may not be always true. So the test is not just a test of your math and English skills. The test is an assessment of your managerial skills. And perception has a huge role to play in your behavioral competence. And this somewhere impacts your final outcome. So wish you all the best. And I hope you understand that myths need to be decoded. They need to be understood. Thank you.